Hello students. In this video we're going to factorize these expressions using what we know about factorizing perfect squares. Now if you look at this first question up here, you might be a little bit perplexed by that because 2y squared isn't a perfect square, so it doesn't fit the pattern of a squared, and similarly the 8 on the end isn't a perfect square, so it doesn't fit the pattern of a b squared. Now we came across a similar problem when we were factorizing previously with a difference of two squares. And what we have to do first whenever we're factorizing is always look for a common factor. And if there is one, take the common factor out first. So if you look at the three terms here, we have a common factor of 2. So the first thing I do is I write that as 2 outside of y squared plus 4y plus 4. Now we can have a look at the term inside the brackets and see if it fits the pattern of a squared plus 2ab plus b squared. Well, if y squared is a squared, then y is equal to a. If b squared is equal to 4, b is equal to 2. And y times 2 times 2, because we have that 2 there, is 4y. So that does fit the pattern of a squared plus 2ab plus b squared. So I can then go ahead and say that's just going to become 2 outside of y plus 2 all squared. So the message or the lesson from this particular question here is first take out a common factor. Once you've taken out the common factor, see if you can factorize any further. Okay, I'll have a go at this one down here. Well, step 1, look for a common factor. Well, the common factor is 2. 2 is a factor of 8, 24, and 18. What's left behind in the brackets is 4h squared plus 12h plus 9. So let's see if this fits the pattern of a squared plus 2ab plus b squared. Well, if 4h squared is a squared, then that means a is equal to 2h. If b squared is equal to 9, that means b is equal to 3. So what is 2ab? Well, 2 times a is 4h, times 3 is 12h. So it does fit the pattern, and therefore this can be factorized as a perfect square as 2h plus 3 all squared. Okay, have a go at the next two questions, and a great big hint, start by taking out a common factor. Okay, let's see how you went. Okay, first off, we got a common factor of 2. So we take out the common factor of 2. That leaves y squared plus 6y plus 9. So the question is that a perfect square? Does it fit the pattern of a squared plus 2ab plus b squared? Well, let's go ahead and find out. So we can say, well, if a squared is y squared, a is equal to y. If b squared is 9, b is equal to 3. And 2 times a times b equals 2 times y, which is 2y times 3, which is 6y. So it is a perfect square. And that means we can factorize it as 2 outside of y plus 3 all squared. And the last one. The common factor has to be 2, leaving 9k squared plus 6k plus 1. Again, let's see if this is a perfect square. So if a squared is 9k squared, a is equal to 3k, b is equal to 1, since b squared equals 1, and 2ab, 2 times 3k is 6k, times 1 is 6k. So yes, it is a perfect square, and that factorizes to be 2 times 3k plus 1 all squared. Okay, so again, the lesson from this video is when you're factorizing algebraic expressions, always start by taking out a common factor. In fact, taking out the highest common factor. Okay, thanks for watching.